Hi students, this is greetings from Dr. Visalakshi, Avinashalingam University, Coimbatore. Today you are in a different session on the subject residential space planning, and the module that we cover today is number 26, Kinetic Systems and Intelligent Systems as Building Components. You may be wondering what these are and where they are placed in an interior. But after the session, after completion of the session, probably you will know they are something that you use in everyday activities. Let us go to the session. Home and commercial interiors in recent years act as spaces which can accommodate many innovative endeavors, which in the wake also try to modify, move or reconfigure components. The first one is reconfigurable spaces, followed by kinetic spaces. The session therefore is intended to generate awareness on such building components which have become an inseparable entity in many buildings with the following objectives. Let's have a look into the objectives. Be aware of portable, reconfigurable and kinetic spaces. Comprehend the concepts of integration of movement into built environments. Differentiate smart homes from intelligent homes, and come to know about sensor-driven systems in the interiors, and also gain knowledge on kinetic and responsive architecture. First, let us have a look at reconfigurable living spaces or kinetic movable structures. The term reconfigurable means rearrangement of the elements or settings of a unit as per the requirements. They are fabricated in ways enabling dismantling and reassembling when required. Living space is nothing but the place where people dwell in. That is, the place where one eats, sleeps, takes rest, cooks, and so on. Reconfigurable living space is a unit that provides all these facilities and services along with the benefit of carrying it along. What do you mean by that? It's being portable by the dwellers wherever they go. There are many such spaces, among which pandals, bamboo houses, technical textile roofings and the like are quite significant. The first one is a pandal. This is a temporary abode, but in reality it is much more than that. Once upon a time, they were made of simple bamboo scaffolding with meters of cloth draped around, but today this cannot be more different. But the pandal is built in all conceivable forms and structures, like replicas of famous temples, parliament houses, mansions, forts, etc. Only difference lies in the material used to drape the framework. The materials used in construction of these pandals are no longer the simple bamboo and cloth, but plywood, plaster, dried leaves, thermocol, or packing materials, just to name a few. So intricate and elaborate are these structures that it is indeed difficult to differentiate the pandals from the real structures. Pandals once adorned all festival sites, fairs, trade fairs, and celebration sites. In recent years, food courts, wedding reception areas, political campaign spots, and such places have made pandals a mandatory inclusion, adding to the pomp and pleasure in celebrations. In India, especially, it has become a popular entrepreneurial avenue. Pandals can be very ornate, resembling a famous monument, or as simple as enclosing a space for shelter purposes. The second one is textile architecture. Nowadays, this concept of pandals has penetrated real construction sites with the advent of the technical textiles in building and home construction, especially in the construction of roofs. This area is also referred to as textile architecture. PVC coated high tenacity PES, Teflon coated glass fiber, fabrics or silicone coated PES are used for their low creep properties. Evidences of their penetration in India are seen in hotels, airport lounges, gallery roofing, in stadiums, etc., though representations of higher order are found in other countries. The third one is the bubble house. This shelter is made out of a lightweight plastic skin that is put on over an aluminum frame. Clothing, fabrics, grass or other materials can be inserted into the skin to create insulation, and it also includes hookups for water and utilities. Minimalist in design, this prototype has a lot of potential to be easily manufactured and deployed. The fourth one that we are talking about is the Recover Accordion shelter. This emergency shelter, first of its kind, is extremely easy to transport and set up, requiring only one person to fix it. Made out of polypropylene, the shelter can form many shapes and provide relief for up to 4 people, while rainwater can be collected from the folds. While it doesn't include a utility hookup, beds or renewable energy generation, it does provide a quick roof over disaster victims' heads. The fifth one is a folding bamboo house. A simple yet elegant design, the origami-inspired folding bamboo house designed by Ming Tang was constructed from bamboo and recycled paper, which could be easily manufactured. That is cheaper too. Tang designed the geometric folding structure after a 7.9 earthquake hit central China. The structures could be folded into many different shapes, allowing a range of structures to be created. The concept of the bamboo house is basically a series of bamboo poles that are assembled to create a rigid shape. Once the shape of choice has been made, it is covered with pre-consumer recycled paper. Not only is this idea environment friendly and a best example for sustainable green architecture, but the structure's design is amazing and would prove a viable alternative to many structures that are supposed to be built. Currently, this may appear only as a concept, but it is hoped that people may come across many of these being built for the future. As they blend with the landscape, affording different styles and dimensions, this origami style may be welcomed by all. Now that you have become aware of a few reconfigurable structures, do a small assignment. Find out in your neighborhood some other reconfigurable structures not mentioned here. I know this aspect would have triggered a curiosity in you to find many others. Of course, there are many others too. Having understood what reconfigurable structures in housing mean, let us go to the next unique aspect in interiors, the integration of motion into the built environment. Here, the building components themselves will move or change positions. The building practically remaining static, many a times people install building components capable of movement either in the vertical, horizontal or an inclined plane. Such movable or kinetic components perform various yet exclusive functions. They are discussed under the following types. Kinetic systems which work on electricity in buildings. Kinetic systems using sensors or HMI in interiors. HMI stands for Human Machine Interface. Other kinetic systems in buildings. Building components operating on sensors. Intelligent kinetic systems. Kinetic architecture and responsive architecture. Among those listed as examples for integrated motion into the built environment, that one that comes first is electrically operated kinetic systems. What are they? Additional charm to an existing and successful functioning of a multi-story building warrants easy circulation of traffic both in normal use and during emergencies. For proper appreciation of building design, due care should be given to the type of vertical circulation provided, number of units needed, and the location, arrangement of design, etc. This depends on the purpose of the building on the one hand, and if it is residential, especially apartments, the number of floors and blocks to be enfolded and peak hour usage, that means the loads to be carried at a time of the system, should also be considered. The means of communication between the various floors through HMI or sensors is afforded by various structures such as elevators or lifts and escalators. There are certain integral parts within the building that alone are kinetic and are used by people to move around within the building. There are even devices installed to carry things to different stories within the building environment. Some of them are conveyor belts, stair lift, vertical conveyors, dumb waiters, and so on. The first one is a conveyor belt. They are installed in industries, factories, and manufacturing units to transfer raw materials to the places of use and for bringing finished goods to the point of store or transportation. They operate either as manually functional units controlled by HMI or as standalone kinetic systems which function on specific aspects like the load applied or so on. Second one is the dumb waiter. Dumb waiters are usually found in star hotels, textile showrooms, jewelry shops, and even departmental stores to transmit goods from one floor to the other. They ease the work of the employees from running from one floor to the another to deliver goods. Many a times, it can be seen as small openings in the delivery counters of many showrooms. Often, they are power-driven automatic kinetic systems or mechanically operated by HMI. Third one is the vertical conveyor. They are another type which facilitate moving of goods in discrete ways. For instance, an aperture with a small door to throw clothes for laundering in the corridors of each floor of star hotels is a common sight. There will be a duct with conveyors which carry the soiled clothes through to the laundrette. Fourth one is a stair lift. They incorporate a mechanical device fixed with a seat of some sort which runs on the rails attached to the balustrade on one side of the staircase like a monorail track. Elderly or physically challenged commuters can be safely transported to any floor they wish to land on. The seats simply glide up and down the rails as in child's play. Modern wheelchairs even are designed to glide on these. All you would have seen them somewhere at some point of some time. Have you ever thought that a small portion of the building alone is capable of moving? That is the speciality of these systems. Next, we will have a look at kinetic systems in interiors which are operated by sensors or HMI. There are mainly 4 such systems commonly seen in many interiors. They are elevators or lifts, escalators, panoramic elevators, and the Skytrain. First one is the elevator. Elevators in buildings, especially homes, are technology-driven devices operating on electric or electronic systems and those which are user-friendly. They have become part and parcel of buildings and have no choice in high-rise buildings than to have elevators. They have also become mandates in commercial and public places. Recent designs come with programmed functions which make their presence compulsory. They have actually become conveniences than the designated function of being comforts or luxuries in earlier periods. They work mainly on HMI, but there are also sensor-driven systems. Nowadays, they are custom fabricated to suit individual needs and preferences for materials and operative use. The second one is an escalator. What is an escalator? Escalators are power-driven automatic staircases installed in commercial places for easy commutation of consumers and traders who throng in large numbers. More often, they are one-way automated stairs, so there will be one for ascending and another for descending in the same floor. They can easily transfer large crowds from one floor to another. public places where they expect extensive commutation in the vertical, like railway stations, airports, malls, multi-speciality hospitals, expensive hotels, restaurants, and spaces visited by floating population prefer escalators. Facilitating transfer of a large proportion of commuters, speed of action, novelty, charm, all cumulatively have welcomed this device. Though many escalators are electronically operated, some function on sensors too. This is an added advantage because they also help to conserve energy in the long run. Next one is the panoramic elevators. Elevators are customized with aesthetics, transparency, and attracting attention of visitors in all flow corridors are the designated functions for which panoramic elevators are designed. They are available as moving, that is, kinetic cubicles, giving the commuters a panoramic view of the floors of the building through the transparent toughened glass enclosure. Hence, commuters have access to an exit from only one side. An added charm is the provision of two cubicles, one for ascending and the other for descending, enabling movement of two cubicles side by side, providing an overlook over the other elevator while in motion. They are definitely a treat to kids who enjoy vertical motion riding. They also function both on sensor technology and HMI. Remember using it recently in a mall during a last shopping day out? Yes? The next one is the Skytrain. The Skytrain is an urban rapid transit system in many countries. It uses fully automated trains running mostly on elevated tracks, and hence the name. Skytrain attendants are present to provide first aid, directions, and customer service, inspect fares, monitor train faults, and operate the trains manually if necessary. They are mostly sensor-driven systems. Dear students, I hope you understood this concept well. Now let us move on to know about other kinetic systems which you may come across in built environments. Other kinetic systems in buildings, what are they? Apart from those listed under the previous categories, there also exists certain building components which are kinetic and operable either manually or mechanically. The most important ones are drawbridges over moat, doorways or revolving doors or partitions which are manual or sensor incorporated, movable partitions which are manual or sensor incorporated, sliding doors, manual or sensor incorporated, and revolving doors. Of course, there are other kinetic components too which are quite common but not noticed as having a kinetic feature. So next aspect is on building components operating on sensors. There are a few other building components which are exclusively designed to operate on specific types of sensors and actuators. They are the innovative devices which have become quite trendy in modern houses and buildings too, which operate on sensors or HMI. HMI here is an interface which works like a remote control. The major ones are automatic doorways, which are access controlled entrances which can be opened only by using a swipe card, biometric, iris sensors, or by sensing body temperature. Other one is hydraulic parking, where program system is used to park cars. Third one is smart or intelligent homes, using intelligent services and devices for various purposes like sensing fire and raising alarm, burglar alarm, activating automatic lighting, AC system, etc. And the last one is access control devices, where they use smart cards. The first one is the automatic door. Automatic doors operate with the help of sensors. Sensors sense what they are meant for, like sound, light, body temperature, iris identification, fingerprints, etc. There are different types of sensors, and the doors are activated by the specific sensors affixed to it. When they sense motion nearby, they trigger the automatic doors to open and then close. Individuals have to come close enough for the sensors to activate and trigger action. That is why a door opens and closes when people pass through at close quarters if they are fixed with sensors to detect motion or body temperature. The sensors are said to be activated within that range. Second one is a multi-level automatic or hydraulic parking system with controllers and visualization. The car park consists of a number of parking rings, each of a certain number of parking places. In the center of all the rings, there is an elevator having an arm. The lift can move on the vertical axis only while the arm can only rotate round the lift axis. A car container is placed at the end of the container arm. Its arm is to keep the car within it while transporting it to the desired place. The container can open or close only if the container arm is in the extended state. A single place on the zero level is reserved for so-called get-insert car gate. The user places his car in the gate and the car is placed in the first free parking space. The user can further request his car. The car will be brought to the same gate. In recent years, there are 3 more such parking systems like vertical rotary parking, stacking and car lift systems. These are also examples for reconfigurable spaces where the systems used for integration of motion into the building environments are facilities that make individuals use space and mobility in an effective way with the help of technology and advancement in materials. The system here facilitates mechanization, rendering physical reconfiguration of the space in such ways as to meet desired needs of parking. The central issues in making these types of systems are human and environmental interaction, that is, which create the changes, embedded computational infrastructures, which create the intelligence, and the physical control mechanisms, which create the kinetics. All such systems are intelligent systems. Do you wonder what benefit we can gain by using such systems? Have a look at the next slide. The achievements that can be reached by having intelligent system cover almost all human life aspects of productivity, efficiency, energy saving, environmental conservation, entertainment, delight and comfort, value for money, social cost benefits and increase in building life. Now let us see what smart and intelligent homes are. Smart or intelligent homes offer an integrated network entity for all devices both within and outside a building that can be operated using a uniform operation interface enabled to run on multiple optional devices like a PDA, PC or a TV screen. They afford a complete home networking system exclusively meeting the trendy needs of residents like assured and increased security not only from burglars but also from potential threats to life and property occurring from leakage of toxic gases, short circuits, faulty wiring, etc. These are achieved by installing detection devices for gas, fumes and smoke, intrusion alarm systems, CCTVs for surveillance and the like. While providing all these benefits through sensor control devices set in a comprehensive network, they are further designed to enable energy conservation by incorporating, for example, time delay switches and automatic sensor detectors which turn off lights when the residents close their front door. Then do smart and intelligent homes differ from one another? Of course, smart homes are different from intelligent homes. How? Incorporation of network devices controlling HVAC, that is heating, ventilation and air conditioning systems, lighting, home appliance operations, motion and temperature sensors, cameras and virtually everything which is internet enabled and qualify well to be referred to as Internet of Things are significant of smart homes. They are absolutely automated homes. Often, many of the devices, for instance, a light source in the living room may automatically turn on every day by the strike of 18 hours as the system is set for the set timing, despite availability of ample natural lighting during the time. Here, the inmates are forced to use artificial lighting when they actually don't require one. Maybe prompt the user to intervene and switch it off till light is required. Contrarily, an intelligent home is one where the sensors detect the presence of light and may get activated only after dusk sets in. Thereby, enabling energy conservation. Therefore, in intelligent homes, not only is energy conservation of prime importance, but user intervention is also minimal. Is that clear now? Have you come across any building or house which has commissioned these systems? Yes. Apart from regular kinetic systems, there are advanced versions of kinetic systems which also incorporate intelligent systems. Let us have a look at what they are and how they function. The intelligent kinetic systems concept qualify that they are architectural spaces and objects that can reconfigure by themselves to meet changing physical demands. They employ the trilogy of structural or civil engineering, embedded systems and computations, and adaptable building structures or architecture. They are so blended to enable achieving demonstrable efficiency in energy use and retention of environmental quality of buildings. Use of these advanced technologies is expected to render more efficient and affordable combinations where saving of both energy and available space gain priority. Don't you feel that all of us would have loved to have a house like that? Based on such technologies, would you believe there are two different types of architectures too? Yes, they are kinetic and responsive architecture. What are they? Kinetic architecture is a concept where buildings are designed so that significant portions can move while retaining structural integrity. A building's capability for motion can be used just to enhance its aesthetic qualities, but can also allow it to respond to environmental conditions and to perform functions that would be impossible for a static structure. Quite nice, isn't it? Practical implementations of kinetic architecture increased sharply in the late 20th century with developments in mechanics, electronics and robotics opening up new architectural possibilities. In 1970, architect William Zook published a book titled Kinetic Architecture, which helped to inspire a new generation of architects to design an increasingly wide range of actual working kinetic buildings. Assisted by new concepts such as Fuller's tensegrity and by developments in robotics, kinetic buildings have become increasingly common worldwide since the 1980s. Quite nice, isn't it? The next one is responsive architecture. This form of architecture or building demonstrates an ability to alter its form corresponding to environmental conditions that surrounds it. The term responsive architecture was coined by Nicholas Negroponte, who first conceived of it while exploring prospects for applying cybernetics to architecture. Negroponte proposed it as a system that could integrate computing power into built spaces and structures with the objective of rendering buildings with better performance inputs. His work moved the field of architecture in a technical, functional and actuated direction. No more are buildings just static structures. The concept of dynamics has penetrated this sector too. We have reached a level where buildings too look like human beings, have started responding to external and internal environments and act accordingly. Hence, mere planning is immaterial. It has to be intelligent planning. While a considerable amount of time and effort has been spent on intelligent homes in recent years, the emphasis here has been mainly on developing computerized systems and electronics to adapt the interior of the building or its rooms to the needs of residents. Structures functioning on actuated tensegrity, computerized interpreters, and programmable models are still topics of in-depth research. This session had introduced you to various concepts in building design which many times go unnoticed despite using them frequently, and a few innovative concepts which are yet to see the light of the day in India. As students with passion for interior designing, you can very well try integrating these concepts to bring out unique plans and designs in building structures, thereby creating a gateway for those new concepts to see a placement also in Indian buildings.